What do you think about number one there? So how do we go about answering that question? Remember how the different groups work, right? So tell me about those 87 people. What do we know about them? Yeah, they have the disease and they got a positive test result. They have the disease and they got a positive test result, etc., etc. So what's their question? A test subject is randomly selected, tested for the disease. What's the probability of getting a false positive? So who are the false positive people? Good job, yeah. They do not have the disease, and yet it came out positive, huh? So 27 out of, and what's the bottom of probability always? The total. So it's the total number. I don't know what that is. Just add all those up, you know.
435.
Oh, it is? Thank you. 435, that's the total of all those numbers. So if you divide that on your calculator, 0.062. Yeah, answer C. That good? No? It's not a given question. Yeah, so Christina's question is a really good one, and there will be, we'll come to given ones. There will be given ones. Yeah, if it said, what's the probability of false positive given that it was positive or something? But you understand, so they didn't tell us, for sure we have somebody that got a positive test result. No, they're just saying out of all the people that took the test, including those that got a positive result, a negative result, that really have the disease, that really don't have the disease, out of all 435 people, what's the chance if you were to grab one of all those people at random that you would get a false positive person? Well, 27 of the people are false positive people out of the whole group. So that's different than a given question. We'll get to a given question. So given is when the denominator changes. We weren't given anything in this problem. We weren't given the fact that we knew for sure they were positive or anything like that. Good. Number two. So in a certain class of students, there's 11 boys from Wilmot, 4 girls from Winnetka, whatever that is, 7 girls from Wilmot, 4 boys from Glencoe, 5 boys from Winnetka, 4 girls from Glencoe. If the teacher calls upon the student to answer a question, what's the probability the student will be a boy? How do we do that? Yeah, you could. It's really just boy over total, huh? I don't want to take the time to make the whole thing. It's just boy over total, right? Remember, probability is always over total unless there's a given, and then the given becomes the bottom, right? You with me on that? So any probability question that you take on the exam in a week, the bottom is always total unless there's a given, and then the bottom's the given, because that limits the possibilities, right? Given does. So the total. So how many total people? I guess we just add them all up. What it is? You guys are on it, huh? So 11, I'll just write it down here. 11, 4, 7, another 4, 5, and 4. And then what's the total number of boys on the top? See, 11 boys there, and what's this? 4 boys there, and 5 boys there. Isn't that 20?
Yeah.
20 out of, what'd you guys say? Out of 35. Divide that on your calculator. I'm getting 0.571. Yeah, it's B. Is that making sense? Anything I can answer on those 2 questions? Feel like you'll be able to do that on the exam in a week? Is that making sense? All right. A sample of 100 wood and 100 graphite tennis rackets. Wood, that's sure old. I used to have a wood tennis racket because I'm old. Are taken from the warehouse. Among these, 12 wood and 17 graphite rackets are defective. If one racket is randomly selected from the whole group, find the probability that the racket is wood or defective. Hint, construct a table. So definitely need a table on this one. Didn't totally need it on the last one, but on this one we do. So, okay, going to make a table. Now, what kind of table? Like, what's going to be in my table? Yeah, so the two characteristics that a racket can have, it can be wood or graphite, and it could be like, it's okay or it's defective. Right, those, and you could, if you put the okay and the defective on the side, the wood, the graphite on the top, it doesn't matter. Just put one of the characteristics on one side, one of the characteristics on the other. And then let's see. Okay, so 100, a sample of 100 wood rackets. Where do I put that 100, at least on my chart? Yeah, that's over here. That's the total wood, huh? And 100 graphite, that's the total graphite. Among these, 12 wood and 17 graphite are defective. So there's 12 wood defective right there, huh? And 17 graphite defective right there. Does that make sense what they're saying? Okay, can I get those other empty boxes? By subtraction, huh? Because whatever is here plus 12 has got to make 100. So if you subtract on your calculator, 100 minus 12, 88. And here 100 minus 17, 83. Good. Now, and let's get the totals down below. This is, if you add these up, 171. And this is 29. Okay, let's go for the question now. What is their question? Find the probability that the racket is wood or defective. So wood, so probability, wood or defective. So what do you do for or? How many are wood or just find them all and add them up, huh? Remember or is add? Remember or is add and is multiply? So how many are either wood or they're defective? Let's go group by group. Are these 88 wood or defective? They're wood. How about these 12? They're wood. All those are wood. How about these 83? They're not wood and they're not defective. So I better not circle that. Put that back to where it was. How about the next group? How about here? Yeah, they're defective. They're not wood, but they're defective. So they're wood or defective. Right? That's like me saying you can apply for this scholarship to Fresno State if you've been to the moon or you grew up in Fresno County. Well, if you grew up in Fresno County or grew up in the Central Valley, then you can apply, right? Or just means one or the other, right? So it's all those. So that'd be 88 plus 12 plus 17 over. Now, was this a given problem? No, there's no given. So the bottom will always be the total. What is the total?
200.
Yeah, if you add these up, either sideways or vertically, you'll get 200, huh? 100 and 100, or 171 and 29, either way, be 200. So it's going to be whatever that is, 117 over 200, 58.5, or 0.585, I mean. What it is? 0.585, which is right there. So that's not easy. You okay with making those tables on that, Tanner? Number 4. In one town, 66% of the adults have health insurance. What is the probability that 4 adults selected at random from the town all have health insurance? Now, what kind of question is that? Here we get into identification and the trickiness of that. Okay, so as you read number 4, let's talk about identification, because that's a lot of the battle on stats says. You read that and you go, what in the world? What in the world? What am I even supposed to do? Let me go look at my notes. Well, did they give me this one says when a probability distribution table is given. Did they give me a table? No. There's no table. So it's not that one. Gambling or insurance? Is that gambling or insurance? No. Okay, number 3. Number 3. Probability exactly, less than, at least, more than. What did they say? 4 adults. Is that more than 4? Less than 4? Exactly 4. And, not only that, no mean is given and no standard deviation. So it's not the newest thing we've been doing. That's how you know it's not one of them normal CDFs or inverse norms, because it never says normally distributed. Notice it never says normally distributed, and there's no mean and there's no standard. That's how you go, oh, it's one of the binomes. See all the binomes? That's a binome question. See how you can recognize that? There's no mean, no standard. It never says normally distributed. And it's talking about exactly 4. Was it 4? Yeah, exactly 4. Exactly 4 adults. What's the probability that exactly 4 adults all have health insurance? So this is a binome. Okay, so what for this is an exactly 4 binome. So yeah, which one is it? Let's go back and look. What do you do for exactly 4? Binome PDF. The other ones are all CDF, right? The greater and less and all that's CDF, cumulative distribution function. But this is PDF, probability distribution function. So there it is. Number of trials, probability 4. It even matches our numbers. Binome PDF. So we want PDF, number of trials, probability, and then the 4 will go right there. Because we want exactly 4. Okay, now that still leaves a little mystery. What is the number of trials? What's that? Well, that'll be the probability, right? The probability would be the 0.66. So that's the probability. What's the number of trials? Yeah, it's also 4. Do you see that? Remember, that's how many times you're trying the thing. Trials, trying. How many times did we ask people if they have health insurance? Well, 4 times. They're saying, what's the chance that 4 adults selected at random all have health insurance? All have health insurance. That means you ask 4 people and exactly 4 out of 4 say, yes, I have health insurance. They could have said, sometimes they will say, well, I think we'll probably see another one that says, you talk to 10 people. What's the chance exactly 4 of the 10 say yes? So then this would have been 10. It's the number of people you talk to. You try out, trials, right? But in this case, it was just 4 out of 4. They just said you ask 4. So it's a little different, huh? We're used to there being another number there. Like you talk to 10 people, what's the chance exactly 4 have health insurance? But this was 4 out of 4. So both the number of trials is 4 and the exact number we want to get is 4. So there it is. Hit the buttons on the calculator. I'm getting 0.1897. Is that one of those answers there? Yeah, see how they rounded them all to 3 places? So I better round mine to 3 places too. Because sometimes students will ask me during the test, Mr. Terrence, how far do we round? And I always just say, whatever the answer says. Does that make sense? Just look at the answers. See how they all rounded to 3 places, at least on this particular question? So then if you're trying to match your answer with theirs, make sure you make it look like theirs. Round to 3 places. So this is the 3rd place. Look to the right. 5 or more. How do you round 189 up? 190. There it is. 190. Does that one make sense? They had said, what's the chance you talk to 10 adults that all have health insurance? It would have been 10 and 10. But if they said you talk to 10, what's the chance at least exactly 7 of them? Would have been 10 and 7. But yeah, as it is, they just said 4, so it's 4 for both. Because that's what the sentence really means, isn't it? Aren't they saying, just make sure you're real with this stuff. It really is real life. Aren't they saying you talk to 4 people and out of those 4, all 4 say yes? Right? So it's out of this number, exactly that number say yes. So wouldn't you agree that the common meaning of that sentence is out of 4 people, exactly 4 said yes? All right. Okay, so number 5. The random variable X is the number of houses sold by a realtor in a single month at the Send-Sums real estate office. Its probability distribution is as follows. Find the mean value of X. How do we do that? Find the mean value. Let's go look at the, let's look at our notes. It says right here, when a probability distribution is given you. That's exactly what we've got, huh? Put the data in L1 and L2. Then stat calc 1var stats, L1, L2. Find the mean. So that's what we do. So we go, this is L1. This is L2. Put the data in your L1, L2. Hit stat calc 1var L1, L2. And grab the X bar number. I'll do it. So I cranked it out. My X bar comes out to be 3.6. Did y'all get that? 3.6. And where's 3.6? None of these. It's a little disturbing, isn't it? But like I promised, there will be a couple none of the aboves. Is that good on that? Feel like you can identify? Want to go to number 6? A 28-year-old man pays $181 for a 1-year life insurance policy with coverage of $150,000. If the probability that he will live through the year is 0.9994, what is the expected value for the insurance policy? Round to the nearest dollar. So if we go to our notes, I think it's pretty clear. Do you see what number it is? On our notes. There it is, number 2, gambling or insurance. Gambling or insurance. So you're supposed to make that table right there that it says, this table. So let's do that. So I'm supposed to go L1, and the table's supposed to be dollars win minus dollars cost to play. And negative dollars cost to play. Negative dollars cost. And then over here for L2, it's supposed to be probability winning, probability losing. That's the probability for both those. Okay. All right. So we're talking about a life insurance policy. So let's see if we can put the numbers in here. So there's 2 different things that can happen when you buy life insurance. You live or die, right? You live or die. Question. So you're either going to live or die, right? So if you die during the year, you win. Financially, anyway. Your family wins, right? Financially, you win how much money? Your family wins $150,000. That's what they win. Minus the cost to play the game. The 181 cost of the life insurance policy. Does that make sense there? And down here, what if you live through the year? If you live, you lose, financially speaking. You negative lose the cost of the insurance policy, $181. Is that making sense? So this is L1, 150,000 minus 81, and then 181 below it. And what's the probability of each of those things? What's the probability of dying during the year and winning financially? Well, 0.9994 is the chance of living through the year. So that goes down here, the chance you're going to live and lose financially. And then this will be 1 minus that, the chance you'll die and win financially. So there's the 4 things we type in. The 2 L1 numbers and the 2 L2 numbers. It's a negative sign When it's on one item, like -7, that would be the negative sign. Whereas if you go 10 minus 7, that would be subtract. So subtract is between two things, two numbers, and negative is when it's just on one number. That's a negative sign, right? Yeah, so it's important. Good question. Right here, you need the parentheses on that one, huh? Because that's only on one number there. That's the negative. And right here, you need the subtraction because that's between two numbers. And here as well. So literally type that in and then hit stat, calc, 1var, and L1, comma L2. And then your X bar will tell the story. I'm getting an X bar -91. There it is. Meaning, on average, you expect to lose $91 for that policy. The insurance company expects to make $91 on average for each of those policies it sells. How are we doing? We good on that one? So a company purchases shipments of machine components, uses this acceptance sampling plan. Randomly select and test 30 components to accept the whole batch if there are fewer than 3. It's a key word there. If a particular shipment of thousands of components actually has a 7% rate of defects, what is the probability that this whole shipment will be accepted? Now those just aren't easy. These are not easy questions. So look, I think we should start with their actual question. The probability the whole shipment is accepted. So that's really their question. What's the probability it's accepted? And then kind of backtrack from there and ask yourself, okay, they want to know the probability it's accepted. What has to happen for it to be accepted? What did they say in the words has to happen for it to be accepted? Yeah, accept the whole batch if there are fewer than 3 defectives. So probability, less, yeah, I'll just write that, good idea. Less than 3 defectives, huh? That's when they accept the whole batch. Less than 3 defectives. Okay, how am I going to figure that out? Yeah, do you recognize it? Yeah, go back to your notes. See, whenever they say less than, exactly, they're saying less than, and there's no mean, there's no standard deviation. That's how you know it's not the newest, it's not the normal CDF or the inverse norm, because they're never saying normally distributed. They never said that, did they? They never gave us a mean or a standard. But they said less than. So you go, oh, it's binom, okay. And they're saying less than. Here it is. Here's the instructions for binom less than. I'm giving the example of 4, but what do you got to do? You got to do binom CDF. So I got to go, okay, it's going to be binom CDF, and then it's number of trials, probability, something or less. Number of trials, probability, and then number or less. Okay, this is where it gets a little tricky. So binom CDF. What's the number of trials? Yeah, we're testing 30 components. Good job, exactly. That's the number of times you're trying, trials. So we're testing out 30 components, 30 trials. What's the probability each time? 7% are bad. So 0.07 is the chance each time that you get a defective, huh? Because 7% of the whole batch is bad. So every time you grab one, there's a 7% chance you got a bad one. And now what do you do for number or less? This is the part that tricks everybody. This will be our last thing here. Yeah, good. Look back. Follow the pattern. See what I gave you an example of less than. See how there's a 4 here? And what ends up here? 1 less than that. Because less than 4 means 3 or less, doesn't it? And so likewise, less than 3 means what? 2 or less, doesn't it? You have to lower that by 1 because that's what it really means. See the pattern there? So that's what you put into your calculator. Let's do that. It's binom CDF, not PDF, right? We only do the PDF for the, exactly, huh? I'm getting 0.6487, yeah, 9, around to 9, huh? 0.649. Is that what you're getting? Oh, there it is. I was looking at the wrong one. Yeah, there it is. It's answer C. I was thinking it was none of the above. I was looking at the answers on 8 there. Yeah, there it is. Answer C.